Thank you for the introduction. It's really a pleasure for me to be part of the Embedded Vision Summit this year and to share my experience about deploying computer vision models in production. The topic I want to talk to you about today is how to measure the performance of computer vision models, and especially in the case that the computer vision model is not the final output of our application. To make this more specific, I want to give you an example of a function I've been working on at BMW, and I'll take this example throughout the whole presentation to explain the different aspects. So what we have here is a function that warns the driver if he's about to run a red light. So this is how it looks like. If you're approaching a red traffic light fast, the function will detect the traffic light and give a sound and optical warning when we are about to jump it. And you can imagine there is like a typical traffic light recognition function behind it, and it will discuss how to measure the performance of this model for this specific function. Let's start with the classical computer vision pipeline. So typically you have a camera image, you put it into some kind of computer vision model that detects objects, and you have on the output some detections or classifications. And for these cases, we have some well-known loss functions and evaluation metrics. Like, for example, for classification, we can use the cross entropy loss, recall precision for evaluation. For regression, we have the mean squared error, and so on. But it gets more difficult if we have another block of functional logic between the computer vision model and the output. And especially if this block uses some additional external information, like, for example, a map. And in this case, a lot of questions arise, like how does the accuracy of my computer vision model correlate to the function, to the accuracy of the final function? How are false negatives propagated throughout the system? How do I train it? How do I evaluate if it's good enough? And even there are situations that arise where you think you made a computer vision model better according to the metrics you know, but the final function actually works worse. So we'll talk about how to deal with this.